All right, so this is the 7th grade PARCC Practice Test 2 Calculator section, problems 1 through 9. The spinner stone is divided into 8 equal sections. The arrow in the spinner is spun once. What is the probability that the arrow will land on a section labeled with a number greater than 3? Enter your answer in the space provided. Enter only your fraction. All right, so greater than 3. So I'm going to circle everything greater than 3. So that would be a 1/4 chance because so that would be equal to 2/8 because I have 2 sections that are greater than 3 out of my 8, which is 1/4. So I would use this button right here. And then I will type in 3. Use the down arrow. 4ths. Where's my 4? 4. All right, and then I'm good to go. Oh my goodness, I put 3/4. It's 1/4. So I will use the up arrow, and I will delete this and put in a 1. There we go. It's a problem of using the keyboard upside down. Problem number 2. A scale on a map shows that 5 centimeters is equal to 2 kilometers in part A. What number of centimeters on the map represents the actual distance of 5 kilometers? So that means that 5 centimeters is equal to 2k, which also means that 2.5 centimeters is equal to 1 kilometer. So if I have 5 kilometers, so I make a ratio. Now I'm turning my ratio into a proportion. I have 5, and this is kilometers. What did I multiply 1 by to get 5? 5. So 2.5 times 5 is going to be 12.5. All right. What is the actual number of kilometers that is represented by 2 centimeters on the map? All right. So if I know that, and this is with a calculator too, of course. I know, and let's start with the original ratio. If I have 2 kilometers for every 5 centimeters, that's going to have to equal, so what did I do to 5 to get 2? Well, I'm going to take my calculator, 5 function calculator, and so I'm going to divide 2 divided by 5. And so I multiplied this by 0.4. So that means 2 times 0.4 to get my, so 0.4 times 2. And so it'd be 0.8 kilometers. And so I'd have to type in So I'd have to type in 0.8 kilometers right there. Let's go ahead and type them in. So I believe I had 12.5, and I had 0.8. Excellent. Moving on to the next one. All right. Lindsay would like to know the number of people in a movie theater who will buy popcorn and ticket. Based on past data, the probability that a person who is selected at random from those who buy movie tickets will also buy popcorn is 0.6. So that means out of 10 people, 6 are going to buy popcorn and a movie ticket. Lindsay designs a simulation to estimate the probability that exactly 2 people in a group of 3 will select selected at random will buy both movie ticket and popcorns. For this simulation, Lindsay uses a number generator and generates random numbers, where 1 through 6 represents a person who buys movie ticket and popcorn, and 7 through 9 or 0 represent someone who just buys a movie ticket. For the trial, Lindsay generates generates 3 numbers. She ran the simulation 30 times and recorded the results. And so these are our results. So, in the simulation, one result was 100, 100. What does this result simulate? So, this one here, this one here represents a person who bought a movie ticket and popcorn. The 2 zeros represent 2 different people who bought a movie ticket but not a popcorn. So let's see which one. No one exactly one. So exactly one person in the group of 3 randomly chosen bought movie tickets and popcorn. All right. Problem B. Use the results in the simulation to estimate the probability that exactly 2 of the 3 people selected at random would buy movie tickets and popcorn. So let's go here, and I'm going to use blue here for the ones that have exactly 2 people who bought movie tickets and popcorn. So 6 and 6 and 2, all 3 of these bought popcorn and movie. We want exactly 2. 3, 4, 2 are all between 1 and 6. All 3 bought popcorn. That's not what we're looking for. 8, 4, and 7. 8 and 7 are between 7 and 9. Only one person bought popcorn here. That's not what we want. 6 is a popcorn. 7, not popcorn. 2 is a popcorn. So that one works. I'll strike. Oh, okay. 5, 6, and 7. 5 and 6 works. 7, no popcorn, so that works. 2, 6, 8. 2 and a 6 bought popcorn, 8 did not. That works. 2, 5, 2, that's 3 popcorn, folks. Nope. 4, 6, and 5, everyone bought popcorn. That doesn't work. 4, 2, and 9. 4 and 2 bought popcorn, 9 did not. 5, 7, 3. 5 and 3 both bought popcorn, 7 did not. So that fits our situation in part B. 1, 0, 0. So it's only 1 popcorn, 2 not popcorns. 8, 1, 8. That's 1 popcorn. 1, 3, 9. That's 2 popcorns. 7, 3, 0. Remember, 0 is no popcorn. So this is only 1 person with popcorn, the 3. 9, 1, 0. 1 is the only one that works. 4, 9, 4. Yes, that's 2 popcorns. 9, 2, 2. Yes. 1, 1, 1, 5, 5. Nope, that's 3 popcorns. 5, 8, 5. Yes, that's 2 popcorns. That's 3 popcorns. This is 2 popcorns. This is 1 popcorn. 3 popcorns. 1 popcorn. Oh, here's 2 popcorns, the 2 6s. Here's 1 popcorn. Here's 1 popcorn, the 1 and the 6. The 6 and the 5, yes. Ooh, the 0 is no popcorn, but the 4 and 4 are. And 1, oh, this is also all 2 popcorns. All right, so of the 30 simulations, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 of 30. So if we have 16 of 30, that can be reduced to, well, 2 goes in below them, 8 15ths. So we go 8 15ths. Next. Number 4. Rosie waxes 2/3 of her car with 1/4 bottle of wax. At this rate, what fraction of the bottle will she use if she waxes her entire car? Enter your answer in the space provided. All right. So, 2/3 of her car with 1/4 of a bottle. So that means that she did 1/3 of her car and in that 1/3 she used 1/8 of the bottle. How did I get that? Well, 1/3 is half of 2/3 and 1/8 is half of 1/4 of the bottle. So the second third is another 1/8, and 1/8 plus 1/8 is 2/8, which is 1/4. So if I add another 1/3 of her car, I have to use another 1/8 of a bottle, and so I end up using 3/8 of a bottle. So let's go back to the question and see if they want how much is left or how much we used. At this rate, what fraction of the bottle of the car wax will Rosie use? So it's how much will she use? So then we go back, use our handy dandy fraction maker. Great. And move on. Number 5. Okay. A circular mirror has a diameter of 12 inches. So let's draw my mirror. And it has a diameter of 6, a radius of 6 because the diameter is 12. What is the area in square units of the mirror? All right. So the area of a circle is going to be pi r squared. Well, the radius is 6, so we have area is equal to 6 squared times pi. 6 squared is 36 times pi. And look, all the answers include pi, so I don't have to multiply the pi out. I just have to know that I'm multiplying 36 times pi. All right. A circular frame that is 3 inches wide surrounds the mirror. What is the combined area? All right. Of the circular mirror and the frame. So now we have a black mirror. And inside my black mirror, let's just call that the frame. There we go. So here's my mirror and the frame. And I would obviously encourage you to draw this on your paper. So we know the radius here is 6. And it says the frame is 3 inches wide. So from here to here is 3. So that means this whole distance here is going to be 9. Oh, so what is the combined area? Well, it's going to be 9 squared pi. 9 squared is 81 pi. So I go ahead and click D. Number 6. Let me get rid of my mirror. All right. The students at Naomi's class sold calendars for a fundraiser this year and last year. This year, the selling price of each calendar was $13.25. I'm going to highlight this because it sounds important. The price this year represents 6% more than the selling price of the year. Okay, great. What was the selling price of each calendar last year? Well, this is 6% more. So, what does that mean? That means that $13.25 is going to be equal to some number. I don't know what that number is, so let's call it X. And 6% more. Well, what does that mean? If it was selling for 100% of the price last year, that would mean it'd be the same, right? but we're adding a 6%. So what is 6% as a decimal? Well, it's 0.06. So we have this 1, which represents the cost last year, plus the 6% increase. So that means 1.06 times x is equal to 13.25. Well, what's the opposite of multiplying both sides by 1.06? That's right, dividing by 1.06. So let's go ahead and divide it. Hold on a second, I gotta yell at my son. Maybe not. Campbell, I'm in the middle of recording a video. You're going to have to wait. All right. Much better. Now for the calculator. 13.25 divided by 1.06. And so last year it gets sold for 12.5 or $12.50. All right. The students in Naomi's class earned 20% of the selling price of each calendar sold last year. Sold this year and last year. At last year's selling price, they sold 650 calendars. This year's selling price, they sold 600 calendars. So, select from the drop-down menu the correct complete statement. Naomi's students in Naomi's class earned more money from the fundraiser. And we have this year, last year, and choose the amount. Okay, so they sold at $12.50. They earned, so I'm going to multiply that by 650 calendars. So this is what they, the total number of income, amount of income they had. But they only got to keep 20% of it, so that's 0.2. So that means last year they got to, they got to keep $1,625, and that's last year. All right, how about this year? This year's selling price was $13.25. You can come in if you want. All right, it was $13.25, and we sold 600 calendars. Oops, that was for you, Campbell. And we sold 600 of these calendars, and so we made $7,950, but we only got to keep 20%. Oh my goodness gracious. I have to do that again, I'm sorry. So 600 calendars sold at $13, so watch out, Campbell, 25 cents. And we only got to keep 20% of it. So this year we only made $1,590. So we can clearly say that we made more money last year by, and so that's $35. So it's $35. I just subtracted those two. All right, number 7. 2 more to go. Alexis chose a random sample of 10 jars of almonds from each of the 2 different brands X and Y. Each jar in the sample has the same size. She counted the number of almonds in each jar. Her results are shown in the plots. We don't want that. Okay, brand X, brand Y. Based on the plots, which statement best compares the number of almonds in the jars from the 2 brands? The number of almonds in jars from brand X tend to be greater than or more consistent. Well, obviously, brand Y is far more consistent, so we know A cannot be right. The number of almonds in the jar brand X tend to be greater and less, no, okay, they don't tend to be greater at all. They are, but they are, and they're more consistent. So we know those two are wrong. Let's strike through those. So much fun. All right, the number of almonds in jar X tends to be fewer and more. I don't think it would be fewer. I think, I don't like that one so much. Nope, I want to do this. Yeah. Finally, the number of almonds in jar brand X tends to be fewer and less consistent. Which one do you think this should be?
That's weird.
Well, I would say Y is more consistent, but not necessarily getting more almonds in that one, if I look at these scatter plots. So let's see if I may have missed it. Number of almonds in jar tends to be greater. Okay, and more, no. Okay, so number of brand X tends to be greater, but less consistent. I would have to go with this one, because we tend to get more from brand X, but it is not nearly as consistent. Okay, last one. Okay, two more, my bad. A train traveled 1/5 of the distance between two cities in 3/4 of an hour. At this rate, what fraction of the distance between two cities can travel 1 hour? Okay, so let's divide this into fourths, shall we? So why would I want to divide that in fourths? I don't really want to. Any ideas there, Campbell?
No.
No? Any ideas? I don't know your name. What's your name? You don't know your name? Okay. I will call you nameless. Do you know where your mom or dad are? Can you take them to the office, please? I have announcements made. All right. Sorry, we had a lost child come in here. All right. All right. So we have 1/4 of an hour plus 1/4 of an hour plus 1/4 of an hour. That strategy worked really well last time, right? And so we need three things that add up together to 1/5, right? So what plus itself is 1/5? Well, 3/15ths, right? So that means in 1/4 of an hour we went 1/15th. And the second 1/4 of an hour we went 1/15th of the way. How did I get this? Well, I just divided it into three. I divided 1/5 into 3 parts. Plus 1/15th. When I add these three together, I get 3/15ths, which is 1/5. Okay, so that's good. So if I add another 1/4, I'll add another 1/15th. So all told, I will go 4/15ths. Now we're on the last question. All right. Each bulleted statement describes how the amount of income tax is determined for yearly taxable incomes in different ranges. Yearly taxable incomes of this much are taxed at 10%. For yearly so the first 8,000 is taxed at 10%, and then everything above that is taxed at 15%. And so then this one is a combination of that. So Mr. Vance's yearly income is brilliant. What is the dollar amount taken out of taxes based on sales? Okay, so first, we're going to have a little list going. So his first, his first 8,925 is taxed at 10%, and 10% of that, and since this is a calculator portion, I know you could do this in your head, right? But I know you love the calculators too. Times 0.1. All right. So that's 892.5. Thank you, buddy.
Yeah, there's no one in the office, but I had a pretty good idea of who it was.
So who'd you leave him with?
His brother.
His who?
You know Ethan Wheeler?
Ethan Wheeler.
6th grader?
Oh, yeah.
Yeah, it's Ethan Wheeler's brother.
He has a younger brother.
Yeah.
Okay. All right, so that means we have a...
He was supposed to take care of him, but he just played football and left him standing outside one of the doors.
And his mother was in the office?
No.
His brother was in the office?
No.
Who's in the office?
No one.
So you left him by himself?
No! So we took him to the office. He wasn't there. And I looked down the hall. I'm like, "Is that your brother?" He's like, "Yeah," and he goes runs to him. So.
Okay. So then. So then this portion is taxed at 15%. So I multiply that by 0.15. And so I owe $4,012. Could you go get Anya from Mrs. Badger? And so I add to that the 800. We're going to leave as soon as I'm done with this problem.
I haven't done my homework.
Well, too bad, so sad. You may not get to go to the party.
Really? When is it?
It's after school, so I don't know.
I can do it after the party.
No, you will not.
I can do it. It's really easy.
Go get your sister, and then we will go home, and you'll be doing your homework.
Hey, but I'm not missing the party.
You may miss the party if your homework's not done well.
Dad!
You chose to play after school instead of do your homework.
No, because you were in a parent-teacher conference.
You could have done your homework next door. Are you sure you want everyone to listen to this conversation? Okay, go get your sister. That must have been very funny for all of you. Mr. Rivera's taxable income is $20. Taxable income is $20 for each hour before taxes are taken out. And Mr. Rivera works a total of 40 hours each week for 50 weeks. How much is what is the dollar amount taken out for taxes based on his taxable income? All right, so first we need to figure out how much he made. So $20 an hour for 40 hours, he makes $800 per week. And he did that for 50 weeks, and he made $40,000. All right, so then let's take out the 8,925, and we know that is going to have $892.50 worth of tax taken out. And when we do that, you will have $31,075 of taxable income yet remaining. Then is tax on $325 at a rate of 15%. And so I'm subtracting these right now because we're going to have $3,750 left over. And so his tax on that $37,325 is at 15%. So that is $4,098.75. And so I add these two things together. Oh, I'm not done yet. Sorry. I was so excited. So then finally gets taxed on this $3,750 at 25%. That's what it says right here. And so he will owe $937.50. So I will add these three values together to get his total taxable income, or sorry, his total tax owed. So we have 932.5 plus 4075 plus 892.5. So that means you will end up paying a total of $5,923.75. All right, so those are the first 9 problems. Hopefully that was helpful. Hey, how's... and